Hi, so this is one of our assignments, a text-based console application named Rock, Paper, Scissor game. We know how it works. Uh, uh, Two players compare each other's choices, and we know that in that game, uh, each choices always beats another choice, right? So, looking at the requirements for this console app, uh, we would see first on uh, one of the requirements that at the start of the game, system will ask for the player's name. So let's see. So right now, the game is running, and you would see that it is asking for the user's name or my name for this case. So let's just type yeah. So actually on this part, um, I've implemented uh, encapsulation, which is part of our OOP topic, and you would see it on this part that class new player uh, accepts a private string name, and that name could be set whenever this public string name is called. So here you could see that we have initialized uh, or instantiated uh, a new player for this class. Uh, so we called it player. So player dot name, which is this public string name, would have the value of whatever you type on the console. So this one would pass in uh, the value of uh, name. In our case, that would be Zuriel. So we saw that here on the right line, where it would display the output, we would see that whenever uh, player.name is called, um, it would always return Zuriel for this program. Okay, so that was one of our OOP topics, and then uh, one of the requirements for this game is that player and computer could then choose between rock, paper, or scissors. Uh, we could actually see it here for the user, but we don't see it for the computer, right? So, looking at the program, upon checking this part, so we would see that we uh, generated a random choice on this uh, array. So the array has R, P, and S, which stands for or represents R for the rock, and P for paper, and S for scissors. So the computer randomly chooses one uh, one option here. So it would be uh, any uh, any of these three choices. So we know in the rock paper scissors game, one option always beats another option. So a tie would always would only appear if both player chose the same option, right? So we would see that here on the result. So I've also added the region, so it would not be uh, e- it would be easier to navigate. So on this part, you could see that it's either just the player beats the computer, or the computer beats the player, or it's a tie. So how does this program knows that? So we would then see another topic that we had in OOP, which is um, inheritance. So the class game item has this default behavior. So uh, you could set the name of the game item, and then uh, it returns false for its behavior. So if we look at class rock and it inherited game item, so you would see that it is also uh, written or coded in the same format as the base class. So you would see that it is called rock, and uh, we have used public override bool beats game item other. So what does that mean? It's just saying that uh, if the other uh, item or game item is scissor, then this rock beats the scissor. So it would return true instead of false, because uh, if it would see the scissors as the other game item. Upon comparing on this portion here, so if my choice, or if the user's choice beats computer's choice, then this prompt will come out, and if the computer choice beats the player's choice, this prompt will come out. So how does it know that it beats the other player? So when the player made the choice at first, you could see here that it initiates a new route. So and then randomly the computer would also pick a choice, and it would initiate a new game item. So those game items chosen would then be compared or would be run into this. So player's choice game item, whatever the game item was, if it's rock paper scissors, it will then return a boolean if it's true or false that it beats the player's the computer's choice. So clearly we could see here, for all the three game item choices, we would see that rock always beats scissor, and paper always beats rock, and scissors beats paper. So that's one of the key aspects of the game, right? And then for uh, another additional requirements that we have uh, for this rock paper scissors game, which is unusual, because we set lives of 3 health points for each player. So 3 health points for the user, and 3 health points for the computer. So whenever you lose one round, you lose 1 health points. But for this game, there is an option for the player to have to use a health potion. So whenever you use a health potion, you regain 1 health. So since health potions are declared here that you only have 1, whenever you use that, it would then become none or 0, right? So that is one part of the game. So let's try to use that in our game. Let's say I'm gonna pick rock, and let's see if I would win this round. Yeah, so definitely the paper defeated my rock on this part. So now you would see that the health potion option only appeared when my health is less than 3. So it's actually in the program, and now we can now choose to use the health potion by typing HP. So here you could see that I gained 1 health points, and then this round would be not won by any players, and it would carry on to another round. So another part or another additional requirements we have for this game is that the same magic potion will save the player from death. In other words, if the player is left with only 1 health points and the computer just made the winning choice over the player during a turn, there's a 50-50 chance that the potion will automatically be used. So we have to restart the game in order to see that, and I have to lose the game, and let's see if that magical potion and the automatic part would appear. Entering the name again, choosing, it's just, oh, right here. So now you could see that the magical potion saved you and you are still alive. So now, even though I lost to AI's paper because I chose rock, and my life before it was only just 1, and if I have consumed the health potion, this option wouldn't appear. So on this part, since I didn't consume the health potion, it automatically saved me, but that is on a 50-50 chance. So let's see in the program on how I made it. So there is a separate class named magical potion. So it the bull used always returns false, because whenever the magical potion it is used, then this is not false already. So we update the magical potion bull used whenever we use the potion. So for this, it asked first if the player didn't use the potion and the player's health is already equal to 0, which is part of our requirements, right? And then there is a 50-50 chance, and I've used next double, which would generate number greater than or equal to 0 but less than 1. So it ranges from 0 to 0.09, right? So you could actually use this to have a 50-50% chance uh, on your programs or projects. So whenever uh, this is true, then whenever this is true, that the player's health is only 0 and the potion isn't used, there is a 50-50 chance that you could uh, be saved for that round. So we could see that inside here, the line, the magical potion saved you, is in here, and then player set gets one health points, or restores one health points, and then we update the potion. Now it's used. So on the following rounds, you wouldn't have the 50-50 percent chance again to save yourself, because we have updated the status of the magical potion that it was already used. Then this one, I've also added a health potion variable here, because whenever the player lost its life and the health potion is equal to 0, or is used, this falls on this category. But if the player's health is 0, and we know that the 50-50% chance wouldn't always appear, so whenever the potion is not used, it would also ask the player if it wants to play again, or uh, it would also fall if you won the game. So whenever those three conditions appear, uh, the program will ask you if you want to play again, because at that phase, or at that situation, you could only just play again or close the game, right? So that's all for my rock paper scissor game. Thank you.